you have set up your math notebook, we are going to be looking at this problem. There is no title, but you may turn to the next blank page when you are ready. All right, there's no title today, but we're going to be looking at this problem. Your problem starts by saying Martin made a batch of brownies. He cut the brownies into equal pieces so that he and his 7 friends could eat a brownie. How many brownies are each friend getting? How many brownies is each friend getting? It tells you in the story. If you're not sure, go back in that story. How many brownies is each friend getting? Marley? They're just getting 1 brownie. They're getting a brownie each. So far, so good? Alright, so he made a batch of brownies. He cut the brownies into equal pieces so that he and his 7 friends could eat a brownie. He put nuts in half of the brownies because some like nuts and some didn't. What fraction of the brownies have nuts? What shape, Brogan, are brownies normally? So I'm going to draw a rectangle.
Well, they're squares.
Okay. Square, rectangle. I know when I make brownies in a pan, I usually use a rectangle pan.
Yeah, but come on, square.
Could you use a circle pan?
Yeah.
Yep. But remember, I like to model with rectangles because it's a lot easier for me to split it up. So here's my pan of brownies. I have to partition, that means split up that pan of brownies, because right now I just got 1 gigantic brownie.
Oh,
And I need to make it so that I have enough brownies so that Martin and his friends each get 1. How am I going to do that?
So how many friends does he have?
Well, Bowen, that's a really good point. Bowen said we need to know how many friends he has. How many friends does Martin have? It does tell us that in the problem. He has 7 friends. Am I cutting my brownie into 7 pieces?
No! You need 8. Counting him.
Oh, yeah. Can't forget Martin. Martin did all the work. He made the brownies. You don't think he's going to get a brownie?
He's gonna get most of the brownies.
It says that he cut the pieces so that he and his 7 friends. How many brownie pieces? I'm not telling you again. How many brownie pieces does he need? Got it? 8. We need 8 equal size pieces. Go ahead and partition your brownie pan into 8.
Can we do it any way we want?
As long as it is fair.
Yeah, 4, 2, 3, 4, 5, 6. Everyone gets 86. No.
Our brownie pieces need to be equal size, as equal as we can, because that's fair. It's not fair if one person gets a gigantic piece and someone else gets a tiny piece. Allison, you're halfway. You're halfway. Alright, so far so good, yes?
Yes, ma'am.
You should have something similar to this. Now, is it wrong if you have all your pieces going up and down, like 8 vertical pieces? Is that wrong?
Like this.
No, that'll work. Not sure that's even. Alright, so we've got our 8 pieces. But that's not what our problem is asking us. It's not asking us how many pieces are. What is our problem asking us? Yikes. I need to figure out which brownies got nuts. If I look at my sentence, it says he put nuts in half of the brownies. So what does that look like? If I'm putting nuts in half of the brownies, what might that look like? Bowen, what do you think that's going to look like?
What might that look like? 1/4 and 1/4.
What do you mean by that? Can you come point to which sections I should color to have brown or to have nuts? Excuse me.
This half.
Oh, okay. So Bowen thinks I'm gonna put some little nuts in this. Bowen thinks this. Whoops.
That's not. That's a big. Yeah, that's a big nut. Okay.
Bowen thinks that section should have nuts. Is he correct? Raise your hand. We're not just yelling out. Lydia, is he correct?
Yeah, because half of them have nuts in the other half.
How did we know that half was going to be those 4 pieces? Stop. How did we know that half was going to be those 4 pieces? Archer?
Because there's 8 and a half of 8 is 4.
Archer saying, hey, I knew there was 8 pieces. You're going to have to wait. And half of 8 pieces leaves you with 4 pieces. That makes sense? So we know that it's got to be 4 pieces with brownies. Sorry, with nuts. How would I count these brownie pieces? Like, what would this one be called? If I were to count them up. Addison?
Those pieces should be called.
How do I count them? Remember?
4/8.
This one is 4/8.
Actually, 1/8.
This one's worth 1/8. What about this one?
1/8.
That one's worth 1/8. What about this one?
1/8.
What about this one?
1/8.
What about this one?
1/8. They're all 1.
What about this one?
1/8.
This one?
1/8.
This one.
1/8.
So each piece is 1/8 of the total. Martin did not get the whole brownie pan. He got 1/8. 1 piece. But our question isn't asking what piece Martin got. Our question says, what fraction of the brownies have nuts? Take a look. What fraction has nuts? Penelope, what you thinking? You know it. 4/8. 1/8, 2/8, 3/8, 4/8. 4/8 have nuts. But hey, wait a second. In my problem, it didn't say 4/8 had nuts. It said a half. That doesn't say a half. That says 4/8. What's happening? Penelope's right. 4/8 have nuts. I can see that. But my problem says that you put nuts in half. That doesn't say 1/2. Jordan, what's happening?
It's the cumulative property because 4/8 is it's the same as 1/2, but it's one.
Okay, we're confusing commutative property and equivalence. You're exactly right. It's just not the commutative property. It is, they are equal. But you're exactly right. 4/8 is worth the same has 1/2. It looks different. And if I cut my tray in half, that looks different, Cole, than if I cut it in 8. But Jordan's exactly right. They have the same value. They are worth the same. Are there any questions? You're going to work on this task with partners.
Yes.
But I'm going to go over what it says so you know what to do. Okay? Our task is about Rudy. And Rudy was asked to partition. We've heard that word partition a lot. Partition just means to share or to break apart, right? In our brownie problem that we just did, we partitioned this brownie pan into 8s. So if you see the word partition, just think, okay, I'm breaking something up, I'm cutting it up, I'm sharing it.
Yep.
Rudy was asked to partition a rectangle into 3rds. His work is below. So there we see what he did. The question I'm asking, is Rudy correct, and how do you know? I've got 2 spaces for you. I've got a spot for lines, because you are going to need to write your answer. And if you'd rather draw something to really prove what you think, I've got some extra space for you to draw if you want to draw something. You have to write your answer in sentences, but some of you I know are going to want to draw something to prove it. You can draw it down there if you want to prove it. So I'm going to say this one more time. This is exactly what Addison just asked. You have to write in sentences. If you want to add a drawing to help prove your answer, you can. But you have to do the sentence part. So far, so good?
Yeah.
All right. We are going to talk about this. But when you are done with your partner, keep this paper at your seat because we're going to share out when I see most everybody is done. So far, so good?
Yeah.
Great. So we had some time to work in teams about this problem. Now, I saw a lot of you end up with the same answer, but I want to share some things that Connor and Paxton were thinking about. And I want you to think about this because this is a pretty good point. Connor said, okay, Rudy had to split it up into 3rds, aka 3 pieces. Did he split it up into 3 pieces?
Yes.
So does that mean he is correct?
No.
Well, does 3rds mean 3 pieces?
Yeah. Yes.
Not
equal.
So that's a very good point. When we hear 3rds, we do think 3 pieces, right, Connor? Yeah. And did he split it into 3 pieces?
Yes.
Yes. I'm hearing a lot of you say yes, but, yes, but. Yes, but what? Raise your hand. Because a lot of you, including Connor and Paxton, got to this thought eventually. But that was a really good starting point of, yeah, we do have 3 pieces, so maybe he is correct.
Well, he was correct.
Ava, what are you thinking?
Yes, but the top one is not the same size as the bottom two.
The top one is not the same size. It's not the same worth. I saw Brogan and Bowen use the words not the same value. Archer, no thank you. We have not equal size pieces. So something that I challenged Paxton and Connor to think about is when I hear words like 3rds, go ahead and write this somewhere on your paper. When I hear words like 3rds, it could be on the back, it could be on the bottom, I don't care. Does that word just mean, and please raise your hand, don't just yell at me. Does that word just mean 3 pieces?
No.
Remember that time I said raise your hand, don't just yell at me? Marley?
No, because they have to be equal to.
When we are dealing with fractions, all fractions, forever until you are an adult, and even when you're old, all fractions have to be fair.
What?
So just because it says thirds and we think 3 pieces, every single fractional value has to be the same worth. So, Marley, you're exactly right. Thirds does not just mean 3 pieces. It means 3 equal pieces. Now we know that equal does not mean they have to look exactly the same. They just have to be worth the same. So far, so good?
Yes.
And I'll give you an example. You do not need to do what I've got in red. You do need to draw or write that. And I'm going to give you an example.
Do I just draw that too?
No. So let's assume this is my box. And I've partitioned it like this. So I have 2 here. So far, so good? I have 2 here. And I have 2 here. Do they look, does each piece look exactly the same?
No.
No. But are they worth the same amount?
Yes.
They are worth 2 pieces. Now, this is a really bad drawing because I'm not drawing them very well. But do we understand that even though they look a little different, they can still have that same value?
Yes.
So when we say things like, okay, we need 3 equal size pieces, that doesn't mean they look exactly the same. It just means they have the same worth. Mason, no thank you. Fair enough? So far, so good? So let's go back to our original question. Is Rudy correct? Raise your hand and tell me. And be ready to back it up. Is Rudy correct? I should see lots of hands because I saw lots of people done. Paxton, is Rudy correct?
No.
He is not correct. How did you know, Paxton?
Because 2 are the same size and the top one isn't the same size.
It's not worth the same amount. It's not going to be worth the same value. Lydia?
I was gonna say no too, but if you like take the top part and put it in the bottom part, there's still a lot more that you need to fill in.
Finish, if you have not, finish. I saw a lot of you drawing an example of what thirds should look like at the bottom. If you want to do that, go for it. Finish this page. Make sure you've answered both parts. Is he correct and how do you know? When you have finished this page and you're happy with it, it may get into the math bin. And we are all transitioning into our math choice board.